Hello everybody and welcome back. I hope you're all doing well. In this video we're going to be looking at question number 6 on our 2010-2011 Alberta High School Math Contest. So hopefully you've given question 6 at least a little bit of a look. I'm going to look at it now for the first time. So we've got Alice, Brian, Colin, Deborah, and Ethel, A, B, C, D, E, are in a hotel. Their rooms are on floors 1, 2, 3, 21, and 40, respectively. In order to minimize the total number of floors they have to cover to get together, the floor on which they get together should be its. So we're looking apparently at something around the 20s, or maybe it's a giant trick and they should all need to meet at floor 4, and they just want to see if they can catch us on this. Okay, so how can we sort of think through this? How can we set this up? How should these how should we visualize people getting together and meeting? So there's some floor that it would be good for them to meet at. Maybe call that floor F. Okay, how far does everyone travel to get to floor F? And then we can add up all of those and try and find an F that makes that as small as possible. Okay, so that's a thought here. Okay, I'm going to make a sort of a nice observation, but I'm gonna say that nobody meets at floor 41 because then everybody's going up. But if they meet between floor 40 and floor 1, for example, floor 30, this person comes down by 10 floors, this person goes up by 29 floors, and so they can actually meet with everyone sort of. What's the best way to say it? If they were to meet at floor 41, this person has to go up by 1, this person has to go up by 41. So we definitely want to minimize. Anywhere they meet between 1 and 40 should be 39 floors for these two people to go through. Which actually I think should be the way to solve the problem. So before I make a formula, let me see if I can just solve the problem. So these outer two people, as long as we meet somewhere between 1 and 40, or even at 1 and 40, these two people combined are traveling 39 floors to get there. 21 and 2, as long as we meet somewhere in between there, both of them combined travel 19 floors, and then, well, 3 is between all of them, so if this person doesn't have to leave, then they don't have to move at all. Whereas if they met on, say, floor 5, these two people are still traveling 19 floors combined. These two are traveling 39 floors combined. But this person's traveling 2 floors. That's not as small as them traveling 0 floors. So it looks like they should meet on floor 3, which of course would give us an answer of none of these. But let's see if we can make a formula here. So if they meet on floor F, and I don't know exactly where floor F is, but the distance that they would need to travel, I'm using absolute values here because I don't know, if they meet on floor 21, or sorry, on floor 22, the person who's on floor 21 has to go up by 1, but they do have to go they do have to go 1 floor. Whereas if they meet on floor 20, it's still a distance of 1 for that person to go down by 1 floor. But now I don't have to specify, okay, is F bigger than this number or smaller than this? We'll work that out in a moment. So very general, to get to floor F takes this distance for everyone. Okay, so that's the combined distance that they all go to get to floor F. But as I say, I think we can make some nice simplifying assumptions. If F is bigger than floor 40, then all of these are negative. So all are less than 0. And then we'd have sort of this expression would be F minus 40 because they're all negative, so absolute values flips them around. You'd have F minus 21, F minus 3, F minus 2, f minus 1. And so the total distance traveled by everyone would be 5f, 6 minus 27, so minus 67. Okay? And the smallest that can be is, well, f has to be at least 41, so f would be equal to 41 would be the smallest there. Okay? Well, we don't want that, so let's assume for a moment that f is less than 40. Less than or equal to 40. But still bigger than 21. Maybe they meet above and 4 of the people move up. Well, then my expression, 40 minus f, well, that's going to be positive, so I don't really, well, non-negative, so I don't need the absolute values. And the other ones, f minus 21, no, sorry, 21 minus f, that was the expression I used, right? Absolute value of 21 minus f, well, if f is bigger than 21, this is negative. And so, in absolute value, it's the same as f minus 21. And the same, the other ones, all the other absolute values have negative numbers in them. So what we get, 40 minus 27 is 13. 2 of the f's cancel out. So the total number of floors that people have to travel to meet, if they're meeting somewhere in here, would be 13 plus 3f. Right? Okay, well, what's the smallest that can be and still have f be bigger than 21? F would be 22. And so the number of floors that they go up would be 13 plus 66, or 79. Actually, I never worked this one out. 5 times, so that'd be 205 minus 67, and that's going to be 138. 138 floors between all of them just to get up to 41? Nah, that's not going to work for us. 79 is better. That's still less floors for them to cover. But maybe if they meet somewhere less than or equal to 21 but bigger than 3, we can get even less. And that's sort of what my reasoning at the start, my very quick reasoning through the problem, would show us. Now we're actually just very, very, very meticulously going through and checking all our cases here. Okay? So if instead f is less than or equal to 21, then these first two expressions here are positive, or at least non-negative, and so they can be left alone. So the number of floors looks a little something like that, and then we get f minus 3, f minus 2, because these ones will have to flip around because they're still negative expressions in here. Okay, well, more of the f's are canceling out. I'll get 40 plus 21 minus 6, so that'll be 40 plus 15. So 65 plus f, and the smallest f can be here is 4. So that'd be 69 floors that everyone travels. Well, that's better. So meeting on floor 4 is looking pretty good. But now, maybe the floor they meet is somewhere between 3 but bigger, or less than or equal to 3 but bigger than 2. So now we can just sort of work these out. What if they meet on floor 3? What if they meet on floor 2? What if they meet on floor 1? And we just work these out. And you may have long since lost interest in this, but I'm just trying to very, very meticulously show you how to go through this in case you saw a harder question. A harder question involving lots of floors and there's a lot of variables to work on. This is what we look at. We look at a nice expression for the total distance, and then we say, okay, where can f be to make me simplify this? Because I can't add with absolute values. But if I know f is in this particular range of values, then suddenly this is not a problem. Okay, here what are we going to get? We'll get 61 minus f. And the smallest, well, f is 3, isn't it? So that'd be 58 floors. Okay, everyone would have to go 58 floors in total. If f was 2, and I don't really see why I'm leaving the f's in here, but that's okay. 1f and 1f, so we'll have minus 3f's. 5 minus 1 is 4, 25, so 65 minus 3f. But that's going to be 59 floors everyone travels. So that's worse. This one's still the best. And for the last one, all these absolute values flip around. And we're left with something minus 5f. 67 minus 5f. F is 1, so this is 62. So the smallest distance traveled is when they all meet on floor 3. So it really is an answer of E that none of these answers are correct. I can see how you might think 21 because it sort of seems in the middle-ish, but it looks like when you have 5 numbers, it doesn't matter what floors they are on. You actually just pick the middle person because the outside 2 will travel the same distance as long as they meet somewhere in the middle, anywhere in the middle. And the next 2 and the next 2 and the next. So if we had 19 people in our hotel on different floors, or probably not even, they don't even have to all be different, the median floor that people are on is the meeting place that will minimize the number of floors that they have to cover. Okay, that's kind of interesting. And you could certainly blow this up and make this a much more interesting question. You could talk about 2 hotels, or maybe it doesn't have to be nice vertical. I seem to recall a few years ago there might have been a question on a Waterloo contest, University of Waterloo paper, that had a grid. So, it was floors on a hotel going this way and floors on a hotel going this way was sort of the idea. But interesting stuff. And so there we reasoned it out at the start and got an answer of E, that the answer should be meet on floor 3. And then we did sort of the painstaking find a formula with absolute values, work with cases, and we still showed that 3 is the answer. But at least in that last case, I know exactly how many floors everyone has to travel. Although we probably could have worked them out in our reasoning situation that we did, or reasoning solution that we did at the start. But either way, we have spent way too much time on question 6. I'm done with it. Let's finish talking about hotels. Let's take a look and see what question number 7 has in store, and we'll take a look at that next time. Okay? Take care.